Hi everyone, so here we are. We are still on chapter 16 and I'm going to teach you about resonance today. Alright, so what I would like you to do first is draw the Lewis dot structure for nitrate. So remember, when you draw Lewis dot structures, the first thing you need to do is you need to count the valence electrons. So the only way you can do that is if you have your periodic table out. Alright? Okay, so nitrogen. What group is nitrogen in? Nitrogen is in group 5, okay? And then we have oxygen. Oxygen is in group 6, and then there's 3 of them, so that's 18. And then we have the -1 charge. So you have to remember, how does it get that -1 charge? Well, it gets the -1 charge by adding electrons, right? So then you're going to add 1 electron to your total. So let's add 1. All right, so let's see. Let's do the math and let's add this up. So 18 plus 5 is 23 plus 1. So 24 electrons. So in our structure, we're supposed to use 24 electrons. Okay, let's sketch it out and let's make it look as symmetrical as possible. So we're going to have nitrogen in the middle. Then we're going to have 3 oxygens attached to it. Okay, then we're going to put in the rest of the dots. And remember that you want to make sure everything obeys the octet rule, so you can put 8 around everything. So let's fill in the rest of the dots. Okay, and the nitrogen also needs 8. Okay, so once you got that down, now you have to check the total to see if it matches to the 24 that we counted. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Too many, right? So now this is where we try a double bond. So we put in a double bond. It doesn't matter where you choose to put the double bond. So we'll put in a double bond, and then what you're going to do is you're going to erase 2 dots on both sides. Okay, so we need to erase 2 dots. Alright, so let's erase these 2 here. And then let's erase 2 on the oxygen. Alright, so now let's add up our valence electrons and see if they add up to 24. Alright, so here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now it works. We have 1 double bond and then 2 single bonds. Now, would it be correct if we put the double bond over here instead? Yeah, it would, right? Or what if we chose to put the double bond on this one here? Then that would also be correct. So this is what we call resonance, where you could rotate the double bond and the Lewis dot structure is still correct, okay? And then the true Lewis dot structure is an average between all of them. So let's draw now all of the other resonance structures. And don't forget, since this one had a charge on the structure, we stick it in brackets and we stick the charge in the upper right-hand corner. So as we draw the other resonance structures, we're going to use a double-headed arrow between each of the different resonance structures. So what we're going to do is, now we're going to rotate the double bond and let's put it over here instead. Okay? And then don't forget, oxygen needs the rest of its dots, right? So that it has 8 around it. So let's put in the rest of the dots. Okay, and then I need to close the bracket, put the charge in the upper right hand corner. Okay, and then let's do the final rotation. So use a double-headed arrow between the structure. That's a bad arrow. Anyway, all right. Let's see. So now it's going to go on this one over here. And I'm running out of space, bracket, charge on the outside over there. And let's fill in the rest of the dots so that everything has 8 around it. Okay, filling in dots. Let's see. Oops. Okay, let me slide this over so we can see what's going on. Okay, and there we go. And let's just make our charge on the outside look a little better. There we go. Okay, so there you can see that this one has 3 resonance structures. Okay, see how we just rotated the double bond? First we put it over here, then we moved it to that one, and then we moved it to the last oxygen. Everything has 8 around it. It still has 24 electrons. So then once again, the true Lewis dot structure is an average between all 3 of these. Okay, so that is what resonance is. It's basically when you have a double bond and you can rotate it and the structure will still be correct. Okay, so let's do another example. All right, I want you to draw the Lewis dot structure for HCN. Okay, HCN. Once again, first step, add up the valence electrons. So hydrogen is in group 1. Oops, group 1. Carbon is in group 4. And nitrogen is in group 5. So when you add this up, this equals 10 electrons. Okay, so now we're going to sketch out the skeleton structure with single bonds first. All right, we always try single bonds first. Then we have to make sure that everything has 8 around it. So then we put in the rest of the dots. Okay, so everything has 8 around it. Hydrogen can only have 2. So remember, hydrogen can never be in the middle. Hydrogen will always be on the outside. All right, so let's count our electrons. 2, 4, 6, 8, 10, 12, 14. Too many, right? So now I'm going to add a double bond. And I'm actually going to put the double bond right there, okay? And that means that I'm going to erase 2 dots on both sides. So let me go ahead and start erasing the dots. All right, so now let's add up the electrons. All right, so 2, 4, 6, 8, 10, 12. Still too many. All right, so we try a triple bond. So let's put in our triple bond. Oops. All right, put in our triple bond, and then we erase 2 dots on both sides again. So those go away, and those go away. Now let's add up the total and see what that will be. All right, 2, 4, 6, 8, 10. Finally, okay, so now it matches with 10. So there's a triple bond right here between carbon and nitrogen. Now, would this structure have resonance? Well, are you going to be able to move this triple bond to this side here? So let's think about that. Can there be a triple bond between hydrogen and carbon? No, there cannot, right? Because hydrogen can only have 2 electrons. If you put a triple bond there, then hydrogen would have way too many, okay? So therefore, this does not have resonance, so no resonance. All right, so once again, resonance is where you move the double or maybe a triple bond and that the structure would still be correct, okay? But in this case, you cannot do that, and therefore, you do not have resonance, okay? Because hydrogen cannot have a triple bond, all right? Okay, that is it for today. Bye.